I hope you're sitting down because what I'm about to say might just rock your cosmos. What if I told you that everything we thought we knew about the age of the universe could be wrong? We're not talking about a minor miscalculation here, we're talking about a theory that could nearly double the estimated age of our universe, from 13.8 billion to a staggering 26.7 billion years. But wait, let's turn back the clock, way back. Imagine an infinite black canvas, then in a fraction of a second, a brilliant flash, the birth of everything we know. This event, known in our scientific parlance as the Big Bang, is the starting line of the cosmic race. And believe me, it's been quite a run. But what's the actual age of our awe-inspiring universe? Well, our best guess, until now that is, pegged the universe at the grand old age of 13.8 billion years. This figure was no shot in the dark. It was meticulously calculated by our cosmic detectives and cosmologists who studied the oldest whisper of our universe, the cosmic microwave background radiation, or CMB for short. But hang on to your space helmets because there's more. Enter another player in this cosmic drama, Hubble's law. Named after the legendary Edwin Hubble, this law relates to the distances and velocities of galaxies, helping us determine just how far our universe is expanding. And if we could hit rewind on that expansion, we'd land right back at that first cosmic kaboom, the Big Bang. These two incredible tools, the CMB and Hubble's law, have guided us to our best estimate of the universe's age, 13.8 billion years. A number that seems as infinite as the cosmos itself. But get ready folks, because that number might be in for a cosmic shakeup. But the lead scientist, Rajendra Gupta, is saying hold my telescope and suggesting that our previous estimates might be way off track. Imagine Rajendra Gupta, a cosmology whiz at the University of Ottawa, sitting up late, poring over data, crunching numbers. Suddenly, eureka! He ends up with a number that nearly doubles the currently accepted age of the universe. You might want to sit down for this one, folks. Gupta suggests our universe could be 26.7 billion years old. His research suggests that our galaxy estimates might be so off the mark, they're not just in the next ballpark, they're on another planet. He's boldly stating that our galaxies could be a mind-blowing twice as old as our current guesstimates. And it's not just a hunch. Gupta's got the evidence to back up his stellar claim. He dusted off an old theory from the shelf, something called tired light, which was tossed around way back in 1929 by Fritz Zwicky. The theory is a bit of a rebel, suggesting that the redshift of photos from distant galaxies isn't just because the universe is growing. It could also be that photons, like weary explorers, lose energy on their long cosmic journeys. Adding more spice to his theory, Gupta introduced time-varying physical constants that stretch the existence of early galaxies across a broader timeline. With these tweaks and turns, he reimagined the universe's age to be closer to a staggering 28 billion years. Now I know what you're thinking, this is a massive claim, but it's about to get even more universe-shattering as we delve deeper into Gupta's cosmic revolution. How do we figure out a galaxy's age? It's an age-old question. Now I don't want to geek out too much, but the simple answer is, it's all about the stars. You see, every twinkling star in a galaxy tells a tale of time. We count their brightness, add some celestial math, and voila, we've got a pretty good estimate of how long that galaxy has been kicking around. But here's the tricky bit. To make this galactic guesswork, we have to make a few assumptions. We've got to assume we know how many sizes and types of stars there are in that galaxy. And that's where things get a bit iffy. We base this on what we see in our Milky Way and nearby galaxies. But is that a fair assumption? Gupta thinks maybe not. Let's step into Gupta's cosmic laboratory and see what he's actually discovered. In his research, Gupta found that if you just tweak that spread of stars slightly to have a few more of those big, beefy, light-giving stars, then these so-called overmassive galaxies suddenly start to make a lot more sense. These aren't just any stars, mind you. We're talking about stars so large and so bright, they make our own sun look like a tiny twinkle light. These are the kind of stars that burn bright, die young, and leave a massive stellar footprint. The scientific implications of this are mind-blowing. If Gupta's right, our entire cosmic timeline could shift, rewriting the history of the universe. If Gupta's study has ruffled some feathers in the scientific community, the James Webb Space Telescope is about to ruffle the entire nest. JWST observed highly evolved galaxies existing only 325 million years after the Big Bang. Imagine that, in a universe so young, stars and galaxies were already forming, growing, and evolving. It's like discovering a mature, complex civilization in what we thought was the universe's childhood. This observation doesn't merely fascinate, it disrupts. It challenges the very models we have of galactic formation and evolution. It's a paradox, something that doesn't quite fit our existing cosmic puzzle. It's the kind of discovery that sparks new questions, drives further inquiry, and makes us reevaluate everything we thought we knew. But wait, before we redefine our cosmic calendars, let's check in with the experts. In the world of cosmology, things aren't always as they first appear. It's a bit like peeling an onion. The more layers you peel, the more there is to uncover. Many experts remain unconvinced by Gupta's theory. Extraordinary claims require extraordinary evidence, they say, echoing the famous words of Carl Sagan. The age of our universe is no small matter. It's the backdrop to our understanding of space, time, and existence itself. So challenging the established 13.8 billion year timeframe requires more than just theoretical speculation. It requires solid, irrefutable proof. Some argue that our existing models of star formation and galaxy evolution have stood the test of time and have been refined and improved with every new observation and discovery. These models have served us well, explaining a myriad of cosmic phenomena, and some scientists believe it's too soon to toss them out the window. Others question the assumptions Gupta's study is based on. Sure, if there were more massive, bright stars in the galaxies, they would indeed seem older. And while Gupta's work is groundbreaking, it has its limitations. His paper mainly considers supernova data, and in the expansive universe of cosmology, relying on one source is a bit of a no-no. Our current understanding of the universe's age comes from a blend of different probes, from analyzing supernovae to galaxy distribution and the measured expansion of the universe itself. Now, that's not to say that Gupta's work doesn't hold promise. It's a reminder that science is never settled, and that there are still mysteries in our universe waiting to be uncovered. But for now, the consensus among experts remains. Our universe is likely around 13.8 billion years old. Our understanding of stars and their distribution in galaxies comes from extensive observation and data. To overturn this, we need solid evidence. The more we learn, the more questions we unearth. That's the beauty of science. It's a never-ending journey of discovery. Today, it's Gupta's theory, challenging our understanding of the galaxy's age. Tomorrow, it could be something entirely different. That's what makes this ride so thrilling. If Gupta's study holds water, it's not just about galaxies being older. It's about rethinking how we interpret the light from the stars, how we understand the formation and evolution of galaxies, and ultimately, how we perceive the entire cosmic timeline. But the story is far from over. The scientific community is bustling with debates, and the launch of the Webb only adds more fuel to this galactic fire. To truly understand the power of Webb, check out our video on the James Webb Space Telescope and its recent findings, which are changing the game and blowing minds in the world of cosmology. So join us next time as we delve deeper into the enigma that is our universe. Until then, keep wondering, keep questioning, and as always, keep exploring the cosmos.